Hi, I'm Miss Hearn. Let's get started. In this video, we're going to look at a question where we're asked to use a certain limit fact, that the limit as theta goes to 0 of sine of theta over theta is equal to 1. This is a good fact to kind of have in your back pocket, have it in your toolbox, ready to go, because it's useful for solving a lot of limit problems. Let's look at this one. We're asked to find the limit as y goes to 0 of the sine of 18y over 11y. Okay, and so what I'd like you to observe is that it would be very easy to find the limit as y goes to 0 of the sine of 18y over 18y, because in this formula or fact that we are asked to use up here, theta is really any unknown quantity that's approaching 0. So if this had been 18y over 18y, we could just give that guy a new name, theta. If theta is 18y, then for y to be going to 0 means that 18y is going towards 0, which means theta is going towards 0 as well. So this would be equivalent to the limit as theta goes to 0 of the sine of theta over theta, which would just be 1. Unfortunately, we don't have an 18y, right? So this is kind of like what we wish we had. But could we take our limit, the limit as y goes to 0, sine of 18y over 11y, and just adjust it a little so that it fits this pattern at least a little bit better? And the answer is yes. We can't get exactly sine of 18y over 18y because we can't change the value of the expression. But what we can do is adjust it so that in the denominator we at least have an 18y. And here's how we do it. And what I would like, this is kind of like my wish right here in this box. What I wish I had is an 18y in the denominator. So I'm going to multiply 11 by 18 over 11. Of course, I can't just do that because I want to. So I have to multiply the numerator by 18 over 11 as well. So this is going to give me the limit as y goes to 0 of 18 elevenths times the sine of 18y divided by 18 elevenths times 11y. And so that's going to give me the limit as y goes to 0 of 18 elevenths sine of 18y over the 11's cancel, so we just have 18y, which is what we wanted. Now this is the same as the limit as y goes to 0 of just 18 elevenths out front of sine of 18y over 18y. Now remember, we already found the limit as y goes to 0 of the sine of 18y over 18y was just 1. So this is going to be taking this limit, this is going to go to 1. So the overall limit will just be 18 elevenths times 1, or 18 elevenths. Right, so notice that when we started with sine of 18y over 11y, we got 18 elevenths. If we had repeated this procedure for any values, let's say sine of ay over by, what do you think the limit would be as y goes to 0? If you said a over b, you'd be correct, and you could prove it using the same steps. So not only is it good to know that the sine of theta over theta goes to 1, but in general, the sine of ay over by goes to a over b. I hope you found this video helpful. If you did, please remember to like it. That helps other students to find the video.